Chapter 1.4 is on polynomials. A polynomial is an algebraic expression that involves only addition, subtraction, and the multiplication of variables. So an example of a polynomial would be 4x squared minus 2x plus 3. And you see you only have addition and subtraction and multiplication. And so you can have division of a variable. So you cannot have 4 over x minus 2 because the variable is being divided by. You cannot have the square root of a variable. So you cannot have 4 root x. And finally, you cannot have the absolute value variable. So the expression of 3 plus x is not a polynomial. So you can name polynomials either by terms or by degrees. Terms are the parts of the expression that are added or subtracted. So if we go back to our example of a polynomial of 4x squared minus 2x plus 3, the terms would be 4x squared, 2x, and 3, because those are the three parts of the expression that are added and subtracted together. Degrees, however, are the maximum number of variables that appear in the term. So if you look at our example of polynomial, you could see that it would be to the second degree, because 4x squared, the 2 is the highest variable that appears in any single term. So the first way to name polynomials is by their terms. So a one-term polynomial is called a monomial. And examples of monomials are x, simply, or you can have long monomials such as 5x to the 5th, y to the 10th, z to the 6th. So that's a monomial. 2 terms are called binomials, 3 terms are called trinomials, and 4 terms, there's no special name, so you call them 4-term polynomial. Naming polynomials by degrees, you have your constant function, which is not raised to any degree, so it's just a number, so 4 or 7. You have first degrees, which are called linear polynomials. So you have 7x, just plain x. If it's raised to the second degree, it's called a quadratic polynomial. So you can have 9x squared. Remember that the amount of terms does not matter for degrees, so you can have 9x squared plus 3x plus 9, and that's still a second term. Third degrees are called cubic. 4th degrees are called quartic, 5th degree is quintic, and 6th degree, there's no special name, so you just call them 6th degree, etc. When naming polynomials, you want to express them in degree and then term. So let's name these 2 polynomials. So you can see that this first one is raised to the second degree, so it is called a quadratic. And there's 3 terms, so it's a quadratic trinomial. This next one is raised to, in total in the first term, there are 5 powers. So it is a quintic, and there's 2 terms, so a quintic binomial. When you're multiplying binomials, you want to remember the acronym FOIL. And FOIL stands for first, outer, inner, last. And those 4 words refer to the order which you multiply terms in binomials. So if you have the equation of x minus 3 times 2x minus 5, first you would multiply the first terms together. So you would get 2x squared. Then you would multiply the outer terms together. So you'd get plus 5x. Then the inner, so minus 6x. And then the last, so minus 15. And that way you get your answer. And this can be simplified to 2x squared minus x minus 15. And that is how you multiply binomials together. So let's do another. So 3x minus 8 times 2x minus 7. So if you remember the acronym, I'll just write it up here, FOIL. So you do the first terms, so 6x squared, and then the outer terms, so minus 21x, the inner terms, minus 16x, and the last terms, plus 56, and you can combine like terms, so 6x squared minus 37x plus 56. And that is your answer. Chapter 1.5 is on equations. When you do equations, you have to know what solving means. And solving means writing the solution set to the equation. So first, you simplify the equation to get x equals n, with an n being a number that it stands for. And so the solution set would be s equals, use a brace to indicate the answer. So this is what you have to end up writing, not this. So let's consider the equation of 3x plus 5 equals 60. So first you want to simplify for x. So you add both sides by 5, so you get 3x equals 21. Divide by 3, x equals 7. However, that's not your answer. You want to write it where s equals, and use the brace, 7. And that is how you solve an equation. One thing you need to be careful of is extraneous solutions. Extraneous solutions are numbers that satisfy a transformed equation, but not the original. So consider the equation x equals 5. You know that because x equals 5, the solution set is 5. But if you multiply both sides of the equation by the expression x minus 2, so you get x times x minus 2 equals 5 times x minus 2, where 5 is still a solution, it satisfies the equation. However, if you substitute in 2 for every value of x, you get 2 minus 2 equals 5, 2 minus 2. You get 2 times 0 equals 5 times 0. So 0 equals 0, which is still true. So you would have the solution set of 2, 5. However, if you plug in 2 to the original equation, you get 2 equals 5, which is not true. And so this is what is called an extraneous solution. One more thing is called an irreversible step. An irreversible step occurs when you multiply both sides of an equation by an expression which could equal 0, which is what we did in the last example. And also dividing by an expression that could equal 0, which could result in you losing a solution. So this would not result in an extraneous solution, but however in a lack of a solution. So if you have the equation x squared equals 4x, and you divide each side of the equation by x, then you get x equals 4. And that gives you the solution set of 4. However, if you look at the original equation again, if you plug in 0 for x, you get 0 equals 0, which means it's true. So your real solution set is 0, 4. And what had happened is you divided by an expression which could equal 0, and so you lost a solution. So now let's look at these two problems. So 3x plus 7 equals negative 8. So in order to solve it, you want to subtract each side by 7. So you get 3x equals negative 15. divide by 3, so x equals negative 5, and your solution set is negative 5. So on this next equation, what you want to be careful of is you cannot just square root each side, because if you square root each side, then you get x equals 4. And while that is true, if you plug in negative 4 to the equation, you still get 16 equals 16, which is true. And so you have to be careful of this when you square root each side of an equation. You have to do plus or minus square root, so you know the solution set is negative 4 and 4.